Hi, calculus class. I went all the way to Canada and I got a Canadian block of ice, and it's melting in metric. It's losing 1 centimeter per minute in each direction. The length, width, and height, they're all melting in the same amount, which kind of makes sense. I mean, if your ice block is going to melt, maybe everything melts in the same amount all the way around. So I'm asking how fast is the volume changing when the length is 50 centimeters, the height's 10, and the width is 8. So obviously we're going to use length, width, height. So this is kind of a nice problem. I like this problem because I don't have to go digging around for too much stuff. I already have a specific length, width, and height in case any of these letters survive the derivative. And I have the rate for dH dt, dW dt, and dL dt because they're all losing 1 centimeter per minute. So, man, I've got it made in this problem, but I am going to have to take the derivative of this with respect to time. So here's the rest of the problem all done out. I'm just going to talk it through with you. I've got a three-way product rule. So the derivative of the first times the other two plus the derivative of the second times the other two plus the derivative of the third times the other two. That's how product rule works. Everybody gets their turn. And if you notice, I'm losing 1 in each of these directions. I could have made them all negatives, and that would make my answer a negative 980. Or I could, and this is how this is the decrease. You know, we're decreasing. So if you leave the negative off, then you have to have an English word to indicate that we've got decreasing volume in this case. You got to indicate that rate stands for a negative amount, or throw a minus sign on it and just call it the change in volume. So either way, you got to somehow indicate that you know what's going on, that this ice cube is melting, this ice block is melting, and we're losing this much volume per minute. So you can see where the L and the W and the H, every time we have just a regular W, it gets replaced by an 8. Every time there's a regular H, it got replaced by a 10. But every rate is replaced by a 1, because that's what the rate was. Huh? Pretty good, huh? I like this kind of problem. It's not meant to be too confusing, not too long. Now here's another one for you. This one's a little bit more complicated, but I'm basing it off a problem we did last class. We've got a lamp, and it's coming down. So you can think of this as being on a stage. The person is 61 inches high. The lamp is coming down 1 inch per second. The person's walking away at, let's see, what does it say? 15 inches per second. And we're wondering how fast the shadow is growing, the typical question, how fast the shadow growing, when the person is 48 inches away. And I'm going to need a height for this. I'm just going to say 68 inches above the ground. So the lamp is getting close to the person's height there. So that's going to make that shadow really long. All right, so let's see what we get. Let's see what happens. We've got to do the, excuse me, the same old proportion, h and 6, excuse me, h and 61, vertical sides. And then remember how x is not a side of a triangle, so I can't use x by itself, but I can use x plus s for the side of the big triangle. So notice that h, big triangle, x plus s, big triangle. So this is a good looking proportion. I'm going to cross multiply so I don't have to use quotient rule. So that's going to give me, I'll use an arrow because you don't want to use an equal sign unless things are equal. That's going to give me HS is equal to 61x plus 61, excuse me, man, 61s. All right. So now I can hit this thing with my derivative with respect to time operator. I'm going to have a product rule here, but the other side is just a constant times a variable. So let's see if we got everything. I'm going to have a dH dt times s plus h times ds dt. So I'll write it like that, h times ds dt. And that's equal to 61 dx dt plus 61 ds dt. Well, let's see what we got here. Boy, there's some stuff we don't know and there's some stuff we do know. I've got the approaching the floor, and that's the change in h, and that's negative. So dh dt is a -1. I'd better make that a negative because it looks like some of this other stuff is going to stay positive. I don't know s at the fixed moment. So you know what we have to do, and I hope everybody in the class realizes, we got to run back up here to this drawing, put in the fixed moment information, and find out everything else that we need to know. You know, what's the other stuff? What do these numbers imply? So we'll probably be using this formula again, rather than the Pythagorean theorem, because we don't know or care about this hypotenuse. So this formula is probably going to get used again. Let's see what else we don't know. dh dt. dh dt, that's the, ds dt, sorry, ds dt. ds dt is the change in the shadow that we care about. So that one's never going to be found. But the h is 68. So I've got a 68 for this thing. I've got a 68. 61 dx dt, that's how fast the dude is walking. That's a 15. I've got a 15 for this spot. And ds dt, that's the thing we care about. So the thing I care about happens twice. We got to get these together eventually. So I've got a 68 and a 61. So let's see. I need s, and I think that's it. I've got the thing I'm looking for. I need to find s. I need to find s at the specific moment. So I'm going to make a little barrier here, and I'm going to use this same formula at the fixed moment. Now at the fixed moment, h is 68. So I've got 68 over 61, and that's equal to x is 48 plus s over s. Cross multiply. I could have used the cross multiply formula. That would have been smarter. So I've got a 68s is equal to 61 times 48. I should have ran that ahead of time. 61 times 48 is 2928. All right, so that's 61 times 48 plus 61s. So I'm going to subtract the 61s from the 68. That's 7s. How do you make a 7? 7s. Hang on, I'm on it. Sorry, you guys. There we go. So the proportion, same proportion as we had, just putting in the fixed moment information for h, finding what s has to be, and the fixed moment stuff for x as well. So I've got the 68 minus 61, 7s equals 2928. That will not be divisible by 7. So s is equal to 2928 divided by 7. And I'll just leave it like that for now. And that's inches. S is just a regular length. So now I know what s is. So my final step is I'm going to have -1, and that's times 2928 over 7. And that's plus, well, look at, I have that 68s, or 68 ds dt minus 61 ds dt. I'm going to make that 7 ds dt. I'm trying to do everything I can. I'm just bringing that over here. And this is still equal to 61 times 15, which I should have multiplied. So I'm going to add this amount over to that side and then divide by 7. So ds dt is equal to 2928 over 7 plus 61 times 15. Give me a second. That's 915. And then this whole thing divided by 7. because of the 7 in front of the DSTT. So it's probably not going to be an integer. Let me give it a try on the calculator. 2928 divided by 7 plus 915 divided by 7. And I'm getting 190.5, let's call it. And that's inches per second. Everything's in inches and seconds. So there's our answer. Wow, that's growing pretty fast. But that makes sense because the person's walking away, the lamp is coming down, and the lamp is almost even with the person because the lamp is only 68 inches off the ground. The person's 61 inches high. So you know that's going to make the shadow really long, and the change in shadow should be really big. And that's what we got. All right, 2 story problems done for you. I will see you in class on Monday.